So good afternoon, everyone. Welcome to another series in the Industry Connect program, where we have with us today Mr. Kiran GS. He's a solution architect with BGSW and has significant experience in the industrial automation area. Uh, so today, he is going to give us an overview of PLC and SCADA technologies and how they are meaningful in industrial automation. So welcome, Kiran, and thank you for being with us today. Over to you.
Thank you. I'll just share my desktop.
Yeah.
Let me know once it is visible.
Yeah, we can see.
Okay.
Perfect. Yes.
I think these things, let it be there. Should be fine then. Yeah. Okay. As introduced, my name is Kiran. I work for Bosch Global Software Technologies based in Bangalore. Of course, Bosch is a conglomerate over multiple countries and head office in Germany. I work for this industrial automation, predominantly having almost like 20 years in industrial automation sectors. Basically, when we say industrial automation, we speak about this control system and obviously the industry 4.0 and IoT solutions. This is my whole breadth, I could say. So coming to Bosch itself, we are almost like 25,000 associates and also located in multiple countries. So there's a brief about Bosch. Specifically from a domain angle, if you see, we work for automotive, high-tech, healthcare, and manufacturing. And now I represent manufacturing from the point of this discussion, the PLC and SCADA systems. Yeah. And of course, if you want to bring in my, let's say, education, I'm from electronics and communication. But if you see, when we talk about this PLC and SCADA, literally, it's not a direct mainstream what instrumentation technology engineering students would foresee. But this is where my passion and interest was there from a machine point of view, and later grew it towards this IT sector. This is how the PLC and SCADA in industry is quite related for me as I work in predominantly industrial automation area. And for today's session, we would be covering mostly this basic overview of the PLC and the SCADA also, and the transformations happening in the PLC and SCADA, because we should not assume that, okay, over the period of time, it was there since almost decades. And what is happening in the current market is also what we are expected to be upgraded ourselves, whether you can call it as upskill or reskill, depends on where you are from your engineering background. So that is where the transformation is very important. Of course, from a relevancy of academia, will focus and a typical professional journey. I would not say it as a career path because it is part of a professional journey through which you can enable your career path. That's how I would sum it up. So from this agenda, first, before going into the PLC and SCADA in industry itself, let's focus one thing here, that from where it is actually positioned, actually the PLC and SCADA. According to this ISA 95, that is the International Association for Automation or Standards for Automation, there is something called automation pyramid. This is what that automation pyramid would look like. And in this automation pyramid, you can see that in a typical manufacturing or an industrial sector, we have in general bifurcated the systems to operation technology and information technology. When we say operation technology, mostly it covers this all this low level field level devices. When we say field level devices, you can think as a motor, valve, even a flow controls and all the input and outputs. From there, from a control level, if you see, these input and outputs are connected to either the PLCs or any other controllers which will be used to control and monitor the process itself. When we say process, it can be many process as simple as pick and place to an advanced PID controller or even any other automation system in a typical manufacturing environment where you want to produce a product instead of manual assembly. An automation system is used in the manufacturing environment for efficiency and productivity purpose. This is what the main control level focuses on. Then comes a supervisory level. That is where the SCADA is positioned along with the other HMI solutions. And then finally, we go for this planning level where MES solutions are there. And then over to the management level where ERP solutions. At the moment, we'll not focus too much on the MES and ERP, but just to give you a hint or an idea behind this one, basically when we want to control an entire manufacturing system right from the production start to a packaging, there has to be some kind of a workflow and all the reports generated from a machine itself. All these are controlled and handled through this MES system. And then if you see from a top level management system, this is where the main commands would flow, which means right from a resource planning to the logistics. Some ERP solutions are used, like in SAP, what we call it as SAP solutions. That is how information would flow like. So if you see that from an angle of data size, the low level devices produces lesser data size and all the way above. So, but from a context of data rate, which means the speed at which the data are generated, in that way, if you see, the field level devices produce more data compared to the other higher levels. And of course, the command flow would come from the management level planning all the way to the field level, and the information flow will happen from the field level to the management level. This is what the ISA would kind of call it as an automation pyramid, bifurcating it as information technology, predominantly focusing on IT kind of softwares, which could be having a connection to a plant or corporate. Of course, certain communication protocols are used. We'll focus on that later. Similarly, operation technology, where this part of SCADA and control level and field levels are there, focus more on the real-time system, on also the control and communication areas, of course, with its own protocols. So from this as a base, where you can imagine where would this PLC and SCADA would fit into the manufacturing or an automation pyramid, will focus on an overview of the PLCs, like what it would be and what it can do it. So in high level, if you say it is, I mean, of course, this session is also for intended not only for an entry level university, and also an exit students also. So for a sake of uh, advantage for the entry level, we'll focus some basics of the PLCs also. Of course, you would have kind of already had some kind of syllabus in your academic. I probably think sixth semester or seventh, not sure about that in the latest context. So either way, if I want to just give you a high level overview, PLC systems are called as programmable logic controllers. Basically, if you see from an architecture point of view, it gets the inputs, which can be any input, whether it is digital or analog inputs of a manufacturing environment. What we simply term those as sensors. Once after getting that, it processes with its program, what the user program, what we say that is where we software engineers would come into picture. Then it can actually control an output, what we typically call them as actuators. So basically, these are industrial controllers which will input and output certain, let's say, actions, which means it gathers inputs and provides some outputs from a sensor and actuator context. What does it really do? Basically, in simple terms, it controls and monitors an industrial equipment. When we meant by industrial equipment, obviously, when we say that machine elements are like motors, cylinders, valves, and even any other input and output, no, it can able to control and monitor. Typically, when we think of a type of PLC, of course, there are many other nomenclatures given, including other than the fixed PLC and modular PLC. There are also sometimes called as compact PLC, small PLCs and all. But relatively, if you see, the fixed PLC type and the modular PLC types are predominant types, or more more often used terms. So fixed PLCs are number of inputs and outputs are fixed, and modular are adaptable. That is how it goes on. And yes, if you could have seen that from a positioning of PLCs, from a automation pyramid, it actually interfaces to your input and output, what we call it as IO, and a SCADA or HMI system. That's how it is positioned. Otherwise, if not to control some simple input and output, it can be also taken up for a solution angle, not only from a communication complex automation, it can also be used for other advanced control systems also. Simple terms, if you see, like conveyor control, robotic cell control, these are all the typical use cases of PLCs. Of course, these things can be done by a PC system, but generally, because of their robust architecture, hardware form, and over the period of time, what is happening is the form factors of the PLCs are also getting minimized, which means you can have a simple your palm size PLCs also available, which are more powerful enough. Of course, along with your input and outputs connected to it. So from this angle, if you see it just, if I want to summarize, it just connects an input and output. It has its own processor with all the programmable memory and data memory. It can interface to remote device using other communication protocols like field bus, Ethernet, and even serial ports. Typically, this would be an overview of the PLCs. Now, from an angle of makers, there are multiple manufacturers of PLCs like Siemens, Omron, Allen Bradley, which are more famous actually. Along with them, we do have from Bosch Rexroth. PLCs are there since decade. And also Bosch is having the latest series of its own controllers called ControlX, which has its own PLCs integrated inside. So likewise, if you see that there are many makers of this PLCs, from your academic background, you may not be able to focus on many programming, let's say PLC manufacturers, but at the same time, you have to focus on the programming language itself. That would be more appropriate. And of course, if you see each of the manufacturer, they will be giving their own set of libraries for programming their PLCs. But what you are supposed to do here is, from this automation pyramid, you could have seen that collect the input from the machine, process this input according to some kind of logic, and set some output. That is where you will be focusing on, provided all these input and output management libraries are provided by this manufacturer themselves. So that would be more apt for you to put your experience and hands-on from a PLC background. That is where we are necessary for us to know how a PLC works. Unlike other software execution paradigm, when we say paradigm, you would have heard about this object oriented programming and all. PLC typically falls under functional flow paradigm, which means you just have some kind of a program which would execute from a functional aspect. And when we kind of think a PLC program, we need to keep in mind that the way in which the PLC operates actually, which we typically call them as scan cycle, which means first it reads, the PLC controller itself will read all the inputs of the system, which we meant to be trying to say it as state of inputs connected. And actually it will execute your custom program in whatever programming language you have done. And then based on this custom program, you would have set some output. That is where it would set an output. And then it might do some housekeeping for memory management or something. And then this scan cycle will continue, which means if you try to relate to a normal software context, it's a big while loop. So of course, when housekeeping context, there may be also something like diagnostics, watchdog, and other stuffs. But otherwise, if you can imagine as if there is a continuous scanning of the input, execution of the program. Based on that one, it will set an output. So in that angle, the same logic will be traversed based on the flow context, not the object or whatever other programming paradigm you can think of. Of course, nowadays the PLC also supports this object-oriented paradigm, from trying to say that, okay, you can have some interfaces, you can have some class, and then you can extend those things and all. You can inherit all those software engineering or the software context also would be there from an object-oriented program context. But typically, it has the scan cycle-based execution always. Yeah, this is what it is important for us to be aware of when we do any PLC program. From a programming itself, of course, we would have known decades ago something called ladder logic was very famous. Whether it is ladder logic or functional block diagram, sequential function chart, structured test, or instruction list, all these are based on this IEC 61131 standard. Yeah. So typically, if for today's generation, it is more common to use this kind of structured text. This is where you can see where we have a ladder logic, something looking like a normally open and normally closed kind of contact circuits, kind of circuit diagram. Basically, in that kind of programming language is what typically was there in decades before, but nowadays it is more of this structured text. Of course, you can even do this functional block diagram, which appears to be looking like a blocks, which means you can see that there is a comparator and a move object or a move block. You can use this simple function flow of functional block diagram, but this implementation of this one can also look like this, which is again a structured text. Also, we have something called sequential function chart, wherein which if you want to do a sequence of operations like step 1, step 2, and maybe some parallel execution, synchronization, which means when we say when this happens, only then that should happen, then you can go for sequential function chart. Again, if you kind of double click, it would appear as if it is again a structured text. So basically, you will end up trying to do more often a structured text and then trying to kind of have a much more simpler view, either as a sequence function chart or as a functional block diagrams. That is how typically a programming language in PLC would look like. So some view over here, it is something like this. Let's take a simple example. If you see a simple structured text point of view, which we also call it as STE programming way. So this is how you can simply kind of declare your variables. And if you see, there are some Boolean variables and even some input-output variables. Here, the IX and QX really represents the actual input of the PLC or on output of the PLC. The input can be typically digital, and we can also refer to even analog input and output too. So in a same variable declaration block, you can declare a program variable and also the physical input output variable too for your use case over here. And of course, from actual program, you can actually write your own program. Here you can see that, okay, there will be some rising edge of signal. Once I get the signal, then there will be some on-off thing. So simply put, whatever you write over here, basically we can term it as a structured text, which can able to control the input and output. But when you try to map this one to the scan cycle, this is how you need to be careful that your output, the physical output, when we meant by physical output, you could have seen that on off, the QX0. This one would be set only when it has fully completed with reading the input, executing the output, executing the program, and then finally setting the output. Till then, might be there is a possibility that a particular signal may not be updated unless it has come to the next scan cycle. That perspective you'll have to take care in any PLC program. Okay, so this is about PLC program in brief. And of course, I'll speak about the PLC and SCADA in total in the next sections coming, but we'll jump onto the SCADA. Yeah. So from a SCADA point of view, if you see, unlike a PLC where it can actually control certain processes, it is here mostly used for some kind of monitoring and acquisition too. But from SCADA, what do we mean by is, as per the acronym, it is a supervisory control and data acquisition, which means, of course, it has software and hardware, but basically it can actually focus on not only controlling from a supervisory level, where we meant by supervisory level, that is a supervisor trying to monitor, as if you see can see here from a supervisory level, a supervisor or a line of in charge will try to focus on what is happening inside each and every machine which is connected to a particular controllers like PLCs and PID to your input and outputs. According to that one, specifically some data acquisition would happen, some control also would happen, and also monitoring would be there. So a context of an acquisition, monitoring, and control. This control can be even local and remote system. A simple SCADA system is visualized over here, but in practical terms, this one would be as simple as this, and but also as complicated as multi PLCs, multi, let's say, PID controllers interconnected between each and every area of your manufacturing environment. So you can visualize this so-called field level control level, not only from one PLC, one PID, but maybe hundreds of PLCs, hundred and PIDs interconnected to a network system and then going to a SCADA. And of course, in the SCADA itself, you can have even distributed. There are multiple architectures in SCADA itself. But from a simplistic point of view, a simple SCADA would look something like this. That is what I have summarized over here. Typically, it will interface the PLCs and the above MES system. And also it might even directly connect to your input and outputs also, and even cloud system. That is what SCADA is about. From a functional aspect, basically, or let's say the traditional use case of SCADA was to actually go for this recording of events, alarms. When I say alarms, if something for a simple thresholding, let's say use case, if a temperature exceeds some threshold value, then the alarm would be generated and then it would be either indicated as an output tower lamp, or it can even try to show it in a SCADA system, maybe something like a blinking LED, or even it can trigger some kind of output, let's say information flow. Similarly, the SCADA system also has some database interface given, which means we can have a history of data through which we can see the trends. So which means that where you typically see all these new age AI, ML, or DL kind of technologies, from a trend analysis point of view, some minimal statistical analysis had been there since decades from a SCADA point of view also, but that was limited to a simple trend. So you can see as if in this diagram, how is the production going on, or how is the number of part counts flowing, or even it can be as simple as whether a particular machine is running healthy or is in a state of error. These kind of typical use case of SCADA system are available. And with this one, basically, as I've mentioned, it gives either the operator or the supervisor to analyze what is happening and then take the next decisive action. Obviously, one decisive action would be like, if there is an error, they will attend to see what kind of error is there. And typically a SCADA system, or even sometimes to a certain extent, a HMI, which is connected to a PLC, can also show the actual error, and the operator can actually try to see what error is there. According to the error, fix would be given. But from an overall context, if a particular HMI based solution is not suffice for a simple operation and needs a complex interconnection, then comes the SCADA system. Of course, I'll not bring in the other term in detail from an angle of, let's say, technology point of view. But at the overview, along with SCADA, we sometimes use a term called DCS, which is Distributed Control System. It has some kind of a difference over SCADA, or rather I can try to say a distributed control system might be having a SCADA system, where the distributed control system can perform a high complex task distributed across the multiple processors, one of them may have a SCADA system also. So which means you can kind of say DCS is probably an advanced version of SCADA system in certain cases. That is how we can try to relate the SCADA and DCS. Okay. So from a product point of view, you could have seen from a PLC, there are multiple PLC manufacturers. Whatever manufacturing based system you get, whether it is Allen Bradley PLC, Siemens PLC, Mitsubishi PLC, or even Bosch PLCs, typically you will end up mostly writing a standard programming from a standard programming languages. Mostly, apart from other programming languages, the IEC based programming standard, that is what we call it as the structured test and all, would be more typical in the PLC programming. But when it comes to a SCADA, it is quite challenging for anybody to keep programming these things. That is where a lot of software products has already been developed, which means it's a complete solution by itself, wherein which you can actually do your own screens, that is the visualization, link it up to a particular input output or a logic. There you might have to do some programming, whether it is the C or C++ or a C# program, depends on what kind of this SCADA products are there. But at the same time, having said that, the PLC manufacturer also they have their own SCADA system. Like for example, Siemens has its PLC called S7 series related PLCs. Similarly, it has the Simatic WinCC SCADA software, which means from a SCADA point of view, you can develop a user interface screen using Simatic WinCC and try to connect all the input output for this UI. From a backend point of view, you can still use the PLC programming language or try to connect to PLC itself, wherein which this Simatic WinCC will connect to the S7 PLC. Hand in hand, it would work as a complete solution. So otherwise, if not a particular PLC has also a corresponding SCADA software, there are multiple other SCADA software which may not be having any PLC with them. But otherwise, typically this is how many SCADA softwares are available. And yes, there is one more called codices visualization, which is typically be useful in PLCs like Bosch PLCs and then back off these kind of codices space, or what we call it as 3S automation related compatible PLCs. You can also have codices visualization. Yeah. But apart from these standard products, we can also integrate that one with our own, let's say, programming language interface. For example, typically LabVIEW is one of the software which can use for a kind of simple application, specifically like test benches or something like this, or scientific process, to even advanced algorithms or even other control processes. It happens to be that a SCADA toolkit is available for LabVIEW also. Likewise, it might be possible that a SCADA toolkit would be there for a MATLAB or probably some other UI toolkit. That is how this could also enable, apart from software as a product, they would also end up sometimes be having some kind of a toolkit, or what we call it as plugins or APIs or drivers, which can be interfaced with our traditional programming environment to have implemented a complete SCADA system. This is also possible from a SCADA software and its plugin context. When we come to this architecture, uh, yes, from an angle of a system, what does the SCADA looks like? Typically, it will have an HMI. That is what you can see that, okay, all the controls you can display. and what is the status of the machines or a line you can also display. Similarly, there would be obviously a communication interface wherein which it has to connect to your PLCs, and then obvious SCADA programming would be there, wherein which your HMI would be trying to connect to the actual program where you want to actually acquire the data, control, send the signal back to the PLCs, or get the data from the PLC for further processing. This would be the typical use case of any SCADA programming. Likewise, you have RTU, what we call it as remote terminal unit, as simple as, let's say, a temperature controller. And obviously a supervisory system from the context of a software, a solution angle to a whole system. If this is a system from an architecture context, typically this is the fourth generation architecture. There are previous architectures also, a run through I can give it. But this fourth generation architecture tries to convey that from your field devices, which can be sensors and actuators, you can try to imagine these are at level 0. These field devices would be interfaced to the level 1, which can be a supervisory computer or a PLC or an RTU. We just now saw PLC can actually get the input and based on the program set some output to control certain input process automation. Similarly, we can have other systems simply an remote terminal unit. It need not have a powerful PLC. So in that way, the field level devices can be termed to have in this level 1. And then comes a newer way of introducing this to a next higher level, what we call it as a supervisory computer. From a level 3 angle, if you see, you will be having supervisory computer or a cloud server. All these things would end up in level 3. And then finally in the level 4, which will have a central server and all. From in this angle, if you see, the architecture over here from a typical SCADA system, first of all, it has a basic requirement of data acquiring, control and all. But at the same time, it has a multiple options to share the data, right? We can actually share the PLC one data to other, or from RTU one data back to the PLC. These things are possible. At the same time, it also gives some flexibility for redundancies, which means if one of the server goes down, you can also take care from the other servers. If there is no need of a central server for the overall, the intermediate things can also be having some kind of a, what we call it as local servers. We can also think from a redundancy point of view. This is a typical SCADA architecture, which is also called as fourth generation architecture. Of course, the previous architectures are simple, from monolithic to distributed to network architecture. Of course, from an angle of transition, if you can see that from where it has started monolithic, it has become a distributed, from where in which where the data sharing and also some redundancy is come. Now that has been connected all the way up to the plant network, or even it might be extended to cloud as per the latest architecture, right? So this is typically a SCADA system and architecture. So what we need to know about overall as a solution, which means if me, who had been a PLC and SCADA software engineer, if I want to say from a software engineering point of view, I have an experience of over cumulatively, if I want to bring in, almost like 10 years in PLC and SCADA and other Industry 4.0 IoT solutions. The rest of the 10 years is more focused in that direction. So if you see, basically, if I want to do a PLC and SCADA software, I would be dealing with multiple things. One of them would be this communication system itself. We saw again this pyramid structure, where in which factory floor we have a lot of input and outputs, then the PLCs, and sometimes the advanced versions of PLC, also called as PACs. When we call PLC as program logical controllers, PACs are all more, or let's say a higher end version of this PLC, an alternative to PLCs, we can say. Yeah. sometimes called as programmable automation controllers. Yeah, this is what it is. But basically, when we are connecting the low level devices, we generally have this so-called lot of communication protocols like Ethernet, IP, Modbus, and even OPCs are available. Above this, when we are connecting the PLCs to the SCADA systems or other next level MES system, typically OPC UA is a standard communication protocol. Of course, there are multiple other protocols like even MQTT also, but OPC is more like industry accepted standard for the whole automation pyramid. So the other view of the same thing here, you can see the field level devices are all connected to, let's say, either Modbus, Ethernet IP, or even EtherCAT based. This EtherCAT communication protocol is more towards this connecting individual machines. Nowadays, EtherCAT has become kind of trend towards this communication with multiple device because of its daisy chain connectivity, which means you can connect between multiple input and outputs in a daisy chain format. One after the other, input of one goes to the output, and output of one, the other one will go to the input of others, reducing the cabling cost and other stuffs. So likewise, if you see, these are connected to the controller and then going for the line level controller. Typically, you will be having either the EtherCAT or OPC UA communication protocol. Of course, there are trends going on from OPC UA even to MQTT from higher level communication. So from a communication angle, you have to typically, when you deal with this PLC and SCADA system, you should also be aware that your program is compatible with these kind of communication protocols also. And it should also have a flexibility to connect to the other systems in multiple ways. For example, if you see a traditional OPC UA can also simply use a technique called request and response. That would be kind of a latent solution from a performance angle. But at least in that direction, OPC UA has already provided a public subscribe method also, which means once I subscribe to certain data, automatically the controllers will keep publishing that data. I don't need to keep on requesting. Automatically data would be published to me as a client. That is how typically it would help in publish subscribe. So this from a communication system, if you see, in that context, uh, let's try to summarize from where this PLC SCADA communication system kind of interrelate. And typical use case would be a production machine, which means if I want to develop a product in a manufacturing environment, other than manual assembly, I might have used some kind of a production machine. To enable this, you may have a lot of mechatronic systems which has all these input and outputs, what we call it as sensor and actuators. You would have an electrical system connecting all this input and output, and the software system. That is where the software system, either from a local or even a cloud or server context, typically connected to internet, would have either a PLC based software, maybe in conjunction with SCADA, doesn't need to be, but yes, it typically ends up with the PLC connected to the SCADA system, which would be networked for some monitoring of input output system, typical use case. Now, if you see from that angle, this is where the PLC programming context will come from a production equipment, or what we call it as frontline operations level 012. And from a SCADA system, it would end up somewhere in this manufacturing operations. That is what you can see this ERP, MES systems and all. No? Somewhere the SCADA systems fall under this area. So typical use case of production machine would look like this, and where it can be useful. Now, we saw there are multiple elements into this. Not only if you think from a PLC or SCADA system, of course, it is mostly software, right? But at the same time, you do need to have some kind of an electrical or mechatronic system knowledge from interfacing level. Why? Because I'll bring the context of a trend happening in this PLC and SCADA, then you can be more aware of that. But otherwise, if you see from an industry point of view, PLCs and SCADA are used almost in every industry segment, be it production, be it capital or consumer, which means from a production point of view, it can be used in automotive, energy and utilities and even transport. Yeah. For example, if you see it from a transport point of view, let's take a metro. Controlling a metro, it has its own SCADA system, it has its own PLCs, and of course, it has the many other mechatronic and electrical systems over there. So in that way, if you see, try to see in that direction, it can be used almost in most of the industrial segments, right from the production of the goods to the capital, which means trying to build a machine itself. Obviously, a machine would have its own PLCs or even an equipment like a controller or something. Similarly, it can also be used in a consumer goods, not from an angle of, let's say, production, but the machine to do these kind of products. And overarching all these things in software industry, typically we would end up doing PLC application programming for control logics. When we say control logics, it can be as simple as pick and place a product to even a testing of a product and even some control logics like what we call it as motion control, process control, PID controls. These are all the typical use cases of this software industries. And of course, you do have this Industry 4.0 and IoT enabling software libraries, which means when you do a PLC program, the intent is not only to control, but also send the data to the next higher level, let's say layers. So there you might have to have some libraries. Sometimes we end up doing the libraries itself, meaning libraries to connect to some hardware's input and output, libraries to have some connectivity solutions, that is communication protocols, whether it is Ethercat or OPC or something like this. We may develop the libraries for that itself. And obviously the latest trend is also from an edge analytics, which means some minimal analytics also can be taught, which means PLCs can be kind of be used like a edge device. But in this one, the architecture of the PLC would be looking a little bit different. As such, PLC would not be just a processor or a controller. It would be one of the element wherein which along with the PLC software, other software also would be typically installed in that controller to give that edge-based experience. This is the typical industry segments. And what is the transformation happening? From decades, we always call from an file layer architecture, you could see that this is what we say that ISA 95 based of automation pyramid, where it distinguishes the OT, the automation technology, and the IT, information technology. But over the decades, what we see here is a convergence of OT and IT happening. That is where you can see that, okay, over the years, the OT and IT are kind of integrated, which is somewhere now coming to be more of IoT based. Of course, don't try to club the OT and IT and try to bring a IoT context to it. But yes, coincidentally, that it is like that. But what we try to say, whether you try to bring in a context of IoT or IIoT, that is the industrial Internet of Things, one and the same, typically where we have more or less a lean pyramid like this, now it would be more of interconnected solution, which means the connectivity from a hardware point of view, the connectivity takes a broader scope in this one. And then going forward, cloud analytics also is important, on top of which you will be doing an applications. And the trend is so happening that where you are trying to write a software, it should be a hardware agnostic. When we say hardware agnostics, simply put, you can take your PLC software, put in any PLCs or most of the compatible PLCs, it should work. That's what the trend is nowadays going on. So in that angle, from a digital transformation point of view, the OT and the IT are kind of converging to become so what we call it as IoT based solutions. Yeah. Likewise, the other perspective to it is like we have this shop floor level PLCs and other controllers. Typically, this is getting shifted from a digital point of view to so-called smart IIoT devices. That's where we were trying to say that right now, a PLC or the SCADA system, it can be connecting directly to the PLC or directly to the input output. An advanced version of it is something like the input and output itself is smart enough to be having a connectivity solution to talk to a higher level. What would be the higher level depends on the abstraction point of view, but otherwise the trend is all these input and outputs, your typical valve or a drive which controls the motors or any other temperature control or something would be having a smart connectivity feature which can connect to even cloud level. That one of the trend we are seeing from a factory or a control level equipment. Similarly, if you see this layer of MES or SCADA and all, and with along with this ERP context, these are slowly trying to be trending towards what we call it as digital twins. Yeah, digital twins are nothing but a virtual or cyber physical representation of a physical machines or an equipment. So in that way, there would be some kind of a data model which can be used for developing a digital twin, which means to say where already we have these kind of PLCs programming running with the input and output. Already the PLCs would be having these kind of simulation, let's say environment, which means without the physical input and output, we can actually simulate a PLC program and try to see whether our PLC program or a workflow, whatever we have done, works well or runs well. But beyond that one, if you want to do actually from a virtual system, how literally my machine would look like, for that angle, if you want to see a typical SCADA in conjunction with this MES system and also the PLC program can be kind of interfaced or interrelated to digital twins. In a sense, to say you still might be having a PLC program which will give you the input and output. Using that one, the trend would be like the traditional SCADA would not be just simply trying to monitor or something, would be more of a digital representation of a physical machine or device themselves. Through this, you can have many features like animations and simulations, like what we call it as kinematic animation or simulation or dynamic simulation also. This can be used in places like virtual commissioning and all, wherein which before the machine is getting ready, which means typically if you try to see when we try to talk about, okay, there is a machine being developed, a software programmer has to wait until the mechanical system and electrical systems are rigged up, and then a software can be tried out. The alternative is the PLC software is already having some simulation environment. There some kind of minimal simulations can be done. But with this digital twin, it's an advanced where in which you can actually kind of give an overview to the end user or the end customer how your actual machine would look like while the machine is still under development. These way some kind of let's say pre-production or post-production, which is what we call it as virtual commissioning, are all the trends which is associated with this PLC and SCADAs. And of course, the higher level data analytics, MLAI are all there from a next layer point of view. But typically from a OT and IT, the trend is more or less towards this direction. So from an academics point of view, you, of course, through syllabus, you would have, I hope you would have learned about these kind of PLCs, outputs, what do you mean by PLC scan and various programming languages, and even timers, counters, and input output operation. But try to also have some awareness and some experience on communication protocols. Why? While we are trying to do most of the programming languages, I mean, most of the PLC programming using these programming languages for a simple pick and place software, it might be possible that you would end up even trying to do some advanced control software like PID control, motion control, or even robotic control. While we do this, the data have to be kind of modeled and then sent across other layers through these kind of communication protocols, which means typically your PLC software or a SCADA system should have these kind of communication interface also. And of course, you should have some deep understanding on the SCADA and specifically the distributed control system, which we talked about. And moving forward, you also have to say that it's not simple some digital input or analog input output connectivity. It's what you are interfacing would be in the future the smart IoT device, wherein which communication protocols and these data modeling would be part of these devices. So some awareness of this smart IoT device and how I can connect to my PLC and SCADA, or rather digital twin, what we want to say, also to be kind of picked up over the period of time. That is where I have given a relevance of how this data models and digital twins are all important going forward. Yeah. Yeah, it's not a career path, but at least a professional journey sense. Like me, I was a maintenance engineer right after me coming from an engineering background. So I was almost working 1.5 years in this maintenance as a maintenance engineer, all the 3 shifts. That's how our PLC and SCADA or these kind of journey would be there. But after that, where we kind of be as a maintenance engineering in any shop floor environment, we get to know about this kind of machine electrical, mechanical, and software maintenance, right? Which means you would be maintaining all this electrical, mechanical, and software, right? During this, you can always pick up how to program a PLC or a SCADA system or any other control logics. Yeah, then you would end up trying to be like what we may call it as automation engineer. That is where the more control logics, simply put, all pick and place process control like PIDs or even this motion or robotics can be thought of. And of course, user interface development for ease of view in the HMI point of view. Then something we can term as automation leads could be one typical journey here, and there are multiple levels in that direction. When I say levels, it's not a hierarchy point of view, it is more or less the depth orientedness point of view. So you can still be a maintenance lead or an automation lead who will be focusing more on this PLC SCADA sensor actuator kind of interfaces and all. Then from an angle of control system lead, you will typically end up doing advanced process controls, algorithm development, even distributed control system, connectivity solution, and advanced robotics too. Then from an IoT specialist, since you already have a good exposure to the PLC and SCADA, either as a software development or as a software integration, which means we saw that many SCADA applications are there, many other, let's say, COT solution. When we say COT solution, commercially off the shelf available solutions of other manufacturers or a service provider, you would integrate what we call it as system integrators. So you'll end up more or less like a system engineer to bring some IoT perspective to your solution. That is where you will interface or integrate all these MES, ERP, DCS, and cloud systems. Otherwise, from a management point of view, you can be a project manager who will be focusing more on quality, commercial, and technology. Yes, of course, the later maintenance manager or plant manager would be typical, but otherwise, this is what is more a reference professional journey of PLC and SCADA in conjunction with the latest trend happening. You can see that it's up to you. How do you want to bring your knowledge from pure OT towards the IT system, which means right from the operation technology expertise, you might have to shift towards the information technology also. It may not be fully kind of adapt to information technology, but at least bridging the OT and IT, which is the biggest problem statement available right now. So when we try to say the biggest problem statement is, you would have multiple PLCs, multiple SCADA systems, and many other systems trying to bring the perspective of IoT in the traditional, the adaptability rate is actually slow. Many significant changes are happened, but from the adaptability point of view, the rate is very slow because most of our solution would be very, very specific to particular domains. The way in which I try to write a PLC or SCADA application for some, let's say, typically example, textile industry might be a little bit different from an automotive industries. So you cannot have that way. In that context, if you see what problem the industries are facing is typically an opportunity for us right now, because right now if you see one direction, if you see from an angle of these kind of diversity, lot of programming requirement would come, but at the same time some convergence also have to happen. So whether you are in the direction of a diversified solution or in a convergent solution is depend upon your passion towards how your programming language or technology or domain expertise you'll have to take care. That's how you will have to take your journey through. Yeah. Otherwise, these are other future references. And of course, as I told, the ISA pyramid can be seen here. Bosch Rexroth Control-X automation is here, which focuses on the Rexroth PLCs, and also other than PLC, it also has some connectivity and other solution. And then hydraulics for you, one use case of this, let's say the remote terminal, like let's say the valve, hydraulic valve, how it is interfaced to PLC and other stuff, how these functional blocks are developed independent of hardware. That use case is available here. Likewise, other, let's say the PLC and SCADA systems reference had been also given here. Yeah, this is what I want to convey, but if there is any questions, I can pick it up now. Otherwise, thanks till then.
No, I think the limited time, I think you covered well. I think you gave a very good overview, and also bridging it with the modern systems like IoT. So just one clarification. So I'm not from an industrial IoT background, but
Mm.
so when we talk of IoT, so I'm assuming that all these different layers that you are mentioning, uh, they will all will have changes, right? Right. For example, you were talking about even edge analytics making its way into PLCs. I was not sure PLCs can have edge analytics because I think PLC is a very small device. So just want to know, why don't you throw some light on how do you see this whole space emerging going forward? So when there are greenfield factories which are being set up with new age uh, like smart factories that we call, uh, what is the role that we have and what students should be knowing about when they
Yeah,
actually venture into completely new age setups?
yeah. So one point I want to make it little more clear. When we meant that, okay, these transitions are happening from an edge point of view also is like typically the PLC as is cannot be used from an edge point of view. The trend in the PLC controllers itself is becoming that PLC as a controller, if you see the Control-X automation point of view, the Bosch PLC at least, and it's quite normal. It can be also kind of be available sooner or later in other PLCs also. I mean, other
Okay.
controllers also. At least in that angle, if you see a controller nowadays, like in this case, Control-X Core, what
Mm.
we can call from Bosch, is typically a Linux-based system.
Oh, is it?
This,
Okay.
yeah, this Linux-based system, specifically speaking, Ubuntu. Yeah, this Ubuntu-based system would have a PLC core
Hmm. Understood.
and also many other apps. So you can
Okay.
imagine as if it's a mobile app for an industry. Like typically trying to say that, okay, I have instead of one controller having to do one thing, now I have a controller which can do a PLC operation, which can do connectivity operation, which means all the connectivity feature, which can
Hmm.
also do a digital twin, simple digital twin implementation, which means a powerful controller which has it can be either way. Sometimes a particular IPC based, yeah,
Hmm.
industrial computer based systems are also there. There this PLC software would become so called soft PLC, or we can call it as
Oh.
software PLC, like that.
Hmm.
So these kind of variants or manifestations are there trending up, so that we can actually leverage not from
Hmm.
a
Interesting.
simple PLC program, but also in relation to other solutions, which means we can give a complete solution for a end use case. The trend
Understood.
is what we might have to focus going forward,
Understood.
other than PLC and SCADA. Yeah,
Hmm.
in that direction,
So,
if you see, please,
hmm. No, no. So that's what. So I was just trying
huh,
to
correct,
mention my understanding. The systems basically will overlap. They'll
correct,
come together and a more comprehensive kind of system doing multiple functionalities and bringing together multiple functionalities. Maybe
correct,
also transitioning some functionality into software.
correct. The smartness is not only there from the low level devices, which means you can say the drives to which controls the motor. Of course, I can bring the context of smart drive, smart,
Hmm.
let's say, valve. You can
Okay.
keep trying to bring an IoT perspective in most of your, let's say, the physical input and output.
Correct.
Similarly, for your PLC, those IoT kind of context is also there. Of course, you can also see some kind of a trend. A particular controller can be either used as a PLC or a IoT gateway also, or it can
Hmm.
be conjunction. Only thing is the processor power you need to see whether just by using a PLC program, high-end PLC program inside that one, can I also add up some IoT operations? It depends on the overall processing. Yeah.
Hmm.
If it is too much of motion control, you can't have both the motion control and the IoT gateway context together running. You will have to limit to motion control because motion control needs a lot of
Okay.
resources. But
Got it.
if it is a pick and place or something like this in conjunction with some minimal robotic control or something, this can be still kind of added up to other gateway or any other solutions. Of course,
Hmm.
edge level, not too much because still a controller has its own limitation, not as if it is a powerful server. Yeah. Of course, the
So,
trends are still happening, but it is too early to talk about. We can also imagine that there would be something like cloud-based factory automation also. That trend is
okay.
still there. Yeah. Might be for sure it would be somewhere in that industry 5.0, where in which you have that human machine and then all the connectivity and all. No, there it might be with the 5G adaptation. This is
Okay.
typically would be part of that.
These so in typical IoT setups, now we talk about this command and control kind of hubs, right? Where I'm just trying to understand, do SCADA systems can play that kind of role, or are they capable of playing that kind of role?
Typically, it is from a SCADA point of view, it is quite limited, but it can be done traditionally because no, there are various different ways to use SCADA itself. But if you see from this angle, right, a simple SCADA system can perform a acquire and then control certain things, but at the same time, an advanced SCADA system can also perform what you are trying to say. So in that direction depends on what kind of implementation goes around. For example, in a SCADA system, you imagine this SCADA system in conjunction with some client server architecture.
Something like
Then
that, yeah.
obviously this would end up to have, okay, the client would more focus on this context of connecting to a server, and the server itself will be connecting to multiple hardwares and all. So
Yeah,
depends
that's
on
what. So like in your diagram here, right? So like
correct,
even in typical IoT setups, like you have a local network, you have 100 different sensors, you will have
correct,
some different machines, you may have some other controllers,
correct.
everything. But
Yeah.
will the SCADA system be at the top and no, will be able to really look at all of them?
Basically, we can bring in like the DCS to be somewhere overarching, because DCS is little bit from an point of view of performance and advancedness. DCS gives better, meaning now you have multiple distributed control system. There
Mm.
inside that one, you may have certain SCADA internally. So
Internally,
SCADA
okay.
would be more focused on like, let's say, of course, from a DCS point of view, it will be more local. But from a SCADA point, it can connect to multiple geographies and all, no? So in that
Okay.
way, the DCS and the SCADA are kind of interrelated, and from an architecture point of view, can be connected through this kind of client and server mechanism and bring some solution out of it. And if you try to see, and of course, this, let's say the screenshot I brought it from Automation Forum. There's a typical way of trying to say, but there are multiple other architectures which you can imagine based on
Okay.
your
Okay. Mm.
innovativeness. Yeah.
Interesting. So
That,
interesting, Kiran.
yeah, that would also be a challenge, which is actually supposed to be addressed in this IT/OT convergence, which I think it would be for the next probably some tech talk we can think of, because that
Mm.
itself, the transition itself is both an opportunity and also a challenge, which the market is addressing towards.
So, just wanted to, are there, maybe you can also, maybe even offline, you can maybe suggest some resources. You did mention some list of resources in your
Hmm.
references, but are there any like events, conferences, or where students actually can get to see such kind of demos or
One
learn more about,
typical would be this way itself, like when you try to come as
or
a fresh
practical
in.
implementations of know how these things are working? Where can they, when will they be able to see?
Yeah, one view here is many, let's say, companies have so-called this academy and university collaborations and all, right. Likewise, even Bosch has this kind of, let's say, industry connect context, wherein which
Okay.
like a diploma people, yeah. So
Uh-huh.
they can come and actually get trained in manufacturing all these kind of, let's say,
Okay.
machine. Similarly, if you think of an intern point of view, wherein which your engineering as an intern want to be part of this software
Hmm.
industry intern, there, if some internship is required from a PLC and SCADA,
Oh,
we do have an connectivity connection to this Bosch, let's say, manufacturing sites itself. So in that way, some exposure would be given.
and
And
possible.
this typically we would end up trying to have these things for our freshers too, because once a fresher has come to specifically
Mm-hmm.
companies like Bosch and all, first thing we'll do, if that fresher is more towards this industrial automation area,
Mm.
we give this industry exposure.
Exposure.
Yeah,
Okay. Kiran.
yeah,
So good, Kiran. Thank you so much. I think insightful. I'm sure students interested to build careers in industrial automation will find this very useful and relevant for a deeper analysis.
yeah.
Thank you
Thanks
for
for
your
this.
time, Kiran.
Yeah, thanks for this opportunity. Maybe in probably in the next tech talks we can probably take deep dive into this PLC
Yeah,
and
maybe I
SCADAs.
think
Yeah,
what would be interesting, I think you talked about no about programming PLCs and taking some specific use cases, or I think you mentioned about the scan cycle,
correct,
where how to program the scan cycle. Maybe some orientation around something like that would be very interesting.
correct. So there we can also address the trends also, what kind of programming complexity we
No,
can address. Yeah,
correct. Some use case based thing I think would be interesting.
sure. Yeah,
Okay, sir.
thank
Thank
you,
you so
sir.
much for the time. I think let's keep connected.
Thank